Hey everyone. So today we're going to be looking at fibers and how to make them concurrent without breaking existing code. So there's been a pretty interesting discussion regarding how to make fibers work in a concurrent fashion without breaking existing code which doesn't expect them to be concurrent. So like an example of that is in Ruby, if you have a loop, this code will execute and it will sleep for 5 seconds. Now, with the thread scheduler, these fibers will all execute, sleep will yield, and this loop will terminate even before 1 second is up. And so that changes the semantics of how fibers behaving. And this was pointed out by Charles Nutter from JRuby, and I really appreciate his feedback. And at first I was, I want to avoid blocking operations. And so for me, like it's kind of natural that this doesn't block. But I guess in the context of existing code, if you do this, fundamentally the semantics are changed. Whether this executes after 5 seconds or almost immediately after the 5 fibers are scheduled. Right, so what I've come up with in response to that is to try and build two kinds of fibers. And I don't want to introduce too much new terminology, but the word that's been used before is exclusive. And an exclusive fiber is one which behaves like a normal fiber as it currently does, even when it's running on a non-blocking scheduler. So what that means is this sleep operation will literally sleep for 1 second and block everything. Now there has been a suggestion from Aragon, from Shuffle Ruby, to call this blocking instead. And I think I prefer exclusive, but I would be interested to hear feedback about what you think makes the most sense. I guess in the context of the code that you look at, blocking true means this sleep operation is going to block. In the context of exclusive, what that means is this fiber will run exclusively. No other fiber will necessarily run while this fiber is doing its thing. I guess it's an open question. Naming stuff is really tricky and everyone has different opinions about stuff. But anyway, I've chosen exclusive at the moment. So I have actually implemented bits of this code already. What I've implemented is the keyword constructor, and I'll show that in a moment. But let's just confirm that this is working. Yes, and what I've added is, at least for debugging, I don't know if it will be in like the final, API interface, but fiber current exclusive. And so the result there is true, the fiber is exclusive. And if we do that, this fiber should not be exclusive, and the default, actually I have no idea what the default, I think it should be true, but I don't know if I've done that or not. Yeah, so the default is true. Right, so what this means is you have to opt in to concurrent fibers, which is a very safe default. I agree with that. But when you use this syntax, which will be a supported syntax in Ruby 3, if everything goes according to plan, this actually hooks into the scheduler, and the scheduler can choose itself to make it exclusive or not exclusive. So generally speaking, with this changed syntax, it will be possible. In fact, like right now, actually I'm not pulling in a scheduler, so it's not going to work. But if there was one and it was working correctly, maybe we'll end up changing it later. But this code should work, and it should be not exclusive. Right, so how does this fit into the scheduler? So the scheduler is per thread, and if you have one process with one thread, that's totally okay. It's just at the scope of thread. Now, I've also introduced now when you are running in your thread, the main, like the top level fiber is exclusive, and threads start off being exclusive, i.e. operations will block, and it's when you opt into a non-exclusive fiber that we need to change this. Now, we wanted this as efficiently as possible, so there's going to be a trick here, because keep in mind that it's entirely possible for us to have two fibers and so we have F and G will resume F, and then F will return. We need to get rid of that. Okay, right, so what the code is going to execute, and it's going to get to line 18, and line 18 is going to jump into this block of code here, and it's going to sleep one, it's going to print out thread exclusive, fiber exclusive, and then resume F. F is going to come in here, it's going to print out thread exclusive, fiber exclusive. Now this one, fiber exclusive should be false, and this one, fiber exclusive should be true. And thread exclusive should just be 1 all the time, because we're not changing it. Now the key point is, when we are in a fiber which is not exclusive, we need to tell the thread scheduler that we are running in a non-exclusive context. So the bug here is that this prints out, this line here is printing out 1. What that means is operations are going to block. And so because this thread.exclusive, it gates the scheduler. So if this is not 0, if this is any number bigger than 0, then the scheduler is not used. So when we're in an exclusive fiber, what we want to do is we want to decrement this to 0. And then when we leave the exclusive fiber, we want to put it back to 1. So what I thought was I'd draw a little picture, because this helped me a lot when I was working on it. And I actually have got this set up. Let's see if this works. So if we have our main fiber, I'm just going to move that a little bit closer so it's better. And the focus is crap. Come on, you can focus. Hold on, let me just try shoving something in there. Focus. Oh, I knew I should use manual focus. Give me a second. And last time this crashed. So if the stream drops out, I'll be back in a minute. Okay, that's better. So this is the main fiber. Every thread has a top level fiber. And when we call g.resume, we're basically coming into G, right? And G is not exclusive, so it can schedule concurrently. And then we come into F. So this is resume, and then this yields at the end of its block. We come back into G, and this yields, and we come back into the main fiber. Sorry, it doesn't look at M very much. Right. And so we start off with the thread exclusive as 1. And when we come into this fiber, we want to decrement it by 1, right? so that it comes to 0. And when it's 0, we allow the thread scheduler to kick in and do non-blocking operations. But when we come out of here, we actually need to put it back to 1, right? So we're going to add 1. And then this one is exclusive. And so we need to make sure that's tracked. So it's going to be +1. And then when we come out of here with the yield, we want to take that 1 off, right? And when we come into here, we will subtract 1. We want to get back to 0. And then when we come back to main, we're leaving the exclusive at the non-exclusive G, and we come back to main, which is exclusive, so we add 1, and then that's back to 1. So this is how this parameter changes as we go through the fibers, and it doesn't matter like what sequence of fibers you have, as long as you do this set of operations, the thread exclusive will always be 0 when you're in a fiber which is not exclusive. So what we're going to do firstly, I said I would show you the keyword part. And this is the first time I ever did keyword arguments in C Ruby. And to be honest, I was a little bit disappointed because it just didn't seem as good as it maybe could have been. So the first thing is you need to define this static ID fiber initialize keywords. There's 2 keywords, and I've just initialized them both to 0. And then this is set up down here inside the init method for this piece of code. Fiber initialize keyword 0 is exclusive, and fiber initialize keywords 1 is pull. You can ignore pull, it's something completely else, esoteric. And so then inside this code, RB fiber initialize keywords, essentially I made a value for pull and a value for exclusive, which defaults to true. And then if there were no keywords passed, if there were keywords passed, so if the keyword split is not no keywords, then we make a new value for the options hash and this array of size 2 for the arguments. We scan the arguments and we put the options hash into the options value, and then we use this function called RB get keyword arguments, and we pass in the options hash those that list of keywords that we set up statically, the fact that there's 2 of them, and then the arguments array. And what it will do is it will read those arguments into that list, and then I just copy it back into exclusive and pull. Now I've heard this is actually not the fastest code. I've heard that it's actually faster to write it in Ruby and have the Ruby just call into the C code with an argument list rather than options. But that's kind of disappointing. So I guess maybe we can try and fix that for Ruby 3 in the C API at least. So yeah, finally we just call fiber initialize with the block that we want to execute. The pull we're going to use, which you can basically ignore, and then whether that is a true or not, exclusive or not. And what that does is that exclusive value is essentially written into the fiber struct. Let me just show you that. Somewhere up the top here, this file is massive. Where is it? So this struct here captures all the state for the execution of a fiber. And the fiber itself just needs to know if it's exclusive or not. So we use a bit field just with one bit. It seems okay to me at the moment. So, right. So what I want to do next is the transition that we looked at on paper. There's actually all fibers have an entry point and an exit point, which is kind of annoying because it's not very, it's different from the beautiful symmetry of yield and resume. And so what that means is when we enter the fiber for the first time, if it's exclusive, then we want to tell the thread you're now running an exclusive fiber. And so fibers, when they're first resumed on their new stack, enter in through this function. This is where fibers come in after they're initialized. And what we want to do here is if fiber is exclusive, then thread plus equals 1. And we probably need to do the same going out. These operations should be balanced. It's entirely possible I'll get this wrong in the live stream and I'll need to come back and revisit it, but let's just throw it here for now. By the way, fiber exclusive is immutable. You can't change it. A fiber is either exclusive or it's not. There's no like provision for changing that halfway through the execution. And that needs to be a minus equals. So if we are on the main thread and we enter into, does that make sense? I think that's right. Anyway, we'll find out soon enough. Yeah, and then there's a switch point, which is where all yield, resume, and transfer operations go through, and that is called fiber switch. And there's actually multiple layers of this implementation. But what we want to do is, this line here is the line where the fibers actually swap their stacks around. So one fiber comes in here and this executes and then another fiber leaves. But actually when I say leaves, the stack frame is completely different. So it's not leaving in the same invocation of this method. It's leaving in the invocation that originally it called to yield. So this function does both resume, yield, and well, all of them, resume, yield, and transfer. And it's a little bit tricky to get your head around it at first. But even I struggle with it sometimes when I'm trying to debug what's going on, because it just can be very confusing. But essentially the invariant we want to maintain around this is when we exit a fiber for whatever reason. So this is before the fiber is going to yield. So in our picture that we drew down, actually let me just switch around, I'll point it out. So this is split into like two halves. And this is the store operation, fiber store. And so before we hit fiber store, we want to go, well, this fiber was exclusive. So we need to like neutralize that out. And then when we come into this one, we go, this fiber wasn't exclusive, so we don't do anything necessarily. Maybe I got these numbers along the bottom wrong, or generalized it too much, but there's essentially before and after, and that's literally that line of code in the middle. So if fiber, now I could be more efficient and probably put this in a variable, but I can't be bothered. Right, so if the current fiber is exclusive, then that means, at some point previously we must have bumped thread.exclusive because we're running a fiber. That fiber is exclusive, therefore at some point, either when we started it off or on a previous call to fiber switch. So what we want to do here is should be decrement. Right, because we're leaving. This is the side that's we're leaving the current fiber. It was exclusive, so we're now going to tell the thread that we're not exclusive anymore. And then on the other side, if the current fiber is exclusive, then we need to tell the thread we are now in an exclusive context, and so like don't use non-blocking operations. Right, so this in theory, if we come back here and do this, let's see if we can figure out what it should do. So let's have a look at what that prints out. So the top level, the thread is exclusive, and the main fiber is exclusive. So what that means is when we go into that, when we go from main to G for the first time, it's going to come into this code. So this is the main fiber, and it's going to execute this bit here, and that is going to decrement thread exclusive to 0, and then it's going to come to here, and it's going to jump into, was it G or F? Yeah, G. It goes into G. G has not been resumed before. It's the first time G is being started up, so it's going to go to start, and that, if the fiber is exclusive, is going to bump exclusive up. And so what that means is, depending on whether this is true or not, we will control whether the thread is exclusive or not. Right, so let's try running that and see what happens. And this is very confusing, so I'm just going to prefix these with like letters. Right, so we started off in the main thread and fiber. The main thread is just the thread for the whole process. There's no multi-threading going on here. It's just so we're always looking at the same thread, but the fiber is changing. So the main thread starts off as exclusive, and the main fiber starts off as exclusive. But when we get into G, which is not exclusive, then we decrement, and we don't increment because it's not exclusive. So that thread exclusive and fiber exclusive is false. But then we resume into F, which is exclusive, and we get that. Now let's consider that when this comes back out, we expect the same results there and the same results there. Okay, that looks like an error. -1. How exciting. I get the feeling that there is something wrong with it might not be necessary to do that. Awesome, what have I just done? I've mashed the keyboard and something has gone horribly wrong. return fiber. I have my microphone right in front of my keyboard. It's kind of annoying. Okay, that looks better. So I may need to think about it more. Actually, to be honest, like some of these things just require mental effort to work through all the different possibilities. And there's not only this, but also transfer, which brings about its own set of complexities. But I believe we do get the correct results with that as well. Yeah, it looks good to me there. So the question then becomes, why does this matter at all? And it's a really good question, because what it in theory controls is the non-blocking operations. So when the thread is not exclusive, when the fiber is not exclusive, we want to be able to do non-blocking operations. And there's been discussion around this too. The initial plan was not to have exclusive fibers and to only have thread selector as the gatekeeper for concurrency. But yet, based on Charles's feedback, I think I agree with him now that we can't change the semantics unless the user opts in. So with that in mind, rather than having thread selector as a gatekeeper, well, it's still a gatekeeper, and then the other gatekeeper was IO non-block equals true. So you had to specify that the IO was going to be non-blocking. If we introduce fibers which are exclusive or not, then I feel like every operation that we can make non-blocking in a non-exclusive fiber should be non-blocking. So I'm kind of excited by that as well in a way. Like it kind of tips me over the edge with regards to this design. I think it's actually fundamentally a bit better. But some of these things just take time to digest, and you have to try them out and see what the impact is. So let's have a look at some of the test code, because I think that's going to be the interesting one to me. We'll have a look at how the tests that currently work will be changed to support this model. Okay, let's just jump over to non-block scheduler. Right. So this was what the code looked like before. And so the gate was that you have to set a scheduler, and then you have to set the IO to be non-blocking. And then within these fibers, that IO would be non-blocking. Now with this updated proposal, the changes that need to be made are down here in the handler for the fiber method, we're going to change this to be that. And now this means any operation in this fiber, in theory, should be non-blocking. That's our desire. We've advertised to the VM. That's what we're after. And so over here in the scheduler, then those lines should no longer be necessary, because now it's kind of accepted that any IO happening in these fibers should be non-blocking. And so I think that's the change in the design and the ergonomics from the developer point of view. And I think that's ultimately better, because one other part that I think makes me more confident in this design is that when you look at this one, there's nothing that says sleep is blocking or non-blocking. And in fact, you can't control it. So now with this design, you can control it. If you want an actual sleep, which just blocks everything, this fiber, even though it's running in the context of a scheduler, will block the whole scheduler. It will sleep for 100 seconds. It will block everything else. And I think that while I'm strongly opposed to people doing that, and I think that it's wrong, ultimately what we can do is we can issue warnings. And that's what we are already planning on doing. So if you write code like this, it will work, and it will maintain the existing semantics, I feel strongly that we'll be issuing warnings to say, well, okay, you chose to use a blocking fiber or do a blocking operation inside a fiber that was exclusive, which basically will stall your whole run loop. I'm really against making it easy for the user to do that because it's a bit of a disaster. It's sort of like the sync methods in Node.js. You really shouldn't use them in any kind of code unless you are writing a throwaway shell script you don't care about. And even then, you probably shouldn't use them because they'll tank your performance. Right, so that's the two fundamental changes. So now we've introduced this exclusive thing, and so the problem that I have now is that I actually didn't even look what I need to do to make that non-blocking stuff the default. The Ruby IO layer is kind of tricky, and so I don't know how far we'll get. I'm getting kind of tired, but I do want to have a go at this because I think it's interesting, and it kind of shows the interaction between the scheduler and the IO subsystem. So let's have a go at it and see how far we get. And in theory, that one. I don't really care about that one because it doesn't use a scheduler. But those tests should pass, which we have to make those tests work. Okay, right, scheduler, enumerator, scheduler. So, do these tests pass now? I have no idea, probably not. Make test or test equal test non-block starter. I'm kind of expecting to either hang or just yeah, it's not really happy, which is kind of what we expected. If we put that back in, these tests should pass. What we want to do is we want to detect that the fiber is not exclusive and do this automatically. Not assigned to that field, but just make it non-blocking. Sort of the same effect. And that one. No is expected, but scheduler blocking. What have I done wrong here? Probably broken something horrible and nothing is going to work. Oh well. Such is life. Let's have a look at the IO stuff, because at least we can look at it. I might not forget the test pass. Sometimes at some point it just gets late and your brain stops working and you just look at code and you're like, okay. It's time to like watch Netflix and go to sleep. Or whatever. Okay. Right. So let's try and figure out how these methods work. This one. Excellent. So this is RB IO wait readable for a given file descriptor. And what this does is it looks up the scheduler and RB current thread scheduler, and then it basically calls wait readable on the scheduler if there was a scheduler. And so this is where the magic happens, because this scheduler can go into NIO for R or IO.select or whatever you want, and call fiber.yield, blah 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 blah, and do all that magic. The problem is when IO is not in non-blocking mode, as in IO.nonblock equals true, this method is never called. So we need to find the point where that decision is made and change its logic so that if the thread is not exclusive, we still go through this code path. That's the critical thing. So I find this code, for lack of elegance, atrocious. I just find it so difficult to read and understand what is going on. I end up jumping through these methods like this, trying to figure out who is calling what. So that's called by this one, file pointer wait readable. I know this is also called by some code and other functions as well, so we might not end up in the right place. IO fill buff, that kind of sounds promising. And let's make this code a bit more readable. Right, so we've got a file pointer. Read internal. If R is less than 0, wait readable. I know that Eric has changed some of this code. I wonder what that does, if that's blocking. Right, okay. So this one, this is blocking read. What this does is it tries to read from the file descriptor, and rethread IO blocking region probably releases the GVL. Internal read func is probably something that just calls read. Let's have a quick look at that. Yeah, it's literally just calling the read system call. And that in and of itself can actually call wait for single file descriptor. That being said, unless the file descriptor is in non-blocking mode, that will never happen. So one way for us to ensure this code path is always followed is to always make sure IO, if possible, is in non-blocking mode. That is one option. So what that means is all of Ruby's IO is going to be set to non-blocking. If we get to this point and we call into this, this method here also invokes the scheduler. This one is more complicated because this is without the GVL, and so it has to acquire the GVL, call into the scheduler, pass that into for and then do it, wait for it and come back out. But that being said, if the user doesn't have a scheduler, even if the IO was non-blocking, if the user hasn't set a scheduler, or the scheduler is exclusive, sorry, the thread is exclusive, this will return nil. This method, by the way, let me just show you how that works, because it probably is not clear how this is actually helping. But this method is not just a getter. It's actually something which has a little bit more logic in it, and that's the magic of how fiber exclusive works. So in here, Ruby current thread scheduler, we get the current thread. For some reason, I decided to assert that the thread was valid. Shows that I don't really trust Ruby to work internally at all. We probably don't need this line, but I figured if we don't do this and we get here, then that's a complete disaster. So maybe it should just be a raw assert. Anyway, right. So if the thread is not exclusive, i.e. exclusive is 0, then it returns a scheduler that's assigned to the thread, if any has been supplied. So this could also be nil if there's no scheduler. If the thread is exclusive, then it returns nil, and that's the magic. So what that means is the thread exclusive controls whether the code at a point which might want to do some non-blocking operation, if the thread is exclusive, it won't return the scheduler, and then that means the code will follow the normal blocking code path. So that's kind of the important secret sauce. So let's come back to no GVL whatever, and not that one. Oh, I don't care about those anymore. What I want to do is I want to find out where IOs are created. And I'm really annoyed that this test is failing because I can make it harder to demonstrate that anything is working. Oh, I guess we have to fix it. Okay. So where is our open? I don't even know how RB IO pipe? Is that a thing? Where are pipes created in Ruby? IO pipe. It says it should exist in IO.c, but no, that's a really old changelog. 1996. Excellent. Let's just see if there's the pipe. Oh, here we go. What? No, PID. Oh, no, I don't want that. Oh, okay, excellent. Okay, right. This is just this amazing thing with Unix system calls that you just end up with giant messes like this. I guess Unix, they never really thought about threading at all. The original system calls didn't consider that threads would ever exist. And I guess that's pretty reasonable. But this is a really huge problem. If one thread creates a pipe and another thread spawns a child process, by default, that child process will inherit the pipes. And because it doesn't know about them, they'll never be closed until the child just exits. And so what you have is you have this thing's called close exec, which means that when you exec the child process, a binary for the child process, it closes all, it closes the IO that has been marked this way, like the file descriptor. But the original APIs don't support it. So some systems have this system call called pipe2, and it takes a file descriptor and a list of options. Oh, look at that. That's perfect. That's what I want. And so this tells it that in the operating system to return a pipe that will have this flag set, so that when the child thread calls fork or whatever, that the pipe will be closed when it executes a child process. Now, if you don't do this, you have a race condition, because you end up doing this, and then the pipe doesn't have this flag set, the close execute flag, and then you need to set it here. And the problem with that is between this line and like this line, if another thread makes a child process, you're back to having like file descriptors floating around all over the place in your processes. So there's a race condition here because of the old system calls, and it's unavoidable actually, which is really unfortunate. And what you can do is you can put a global mutex around all of these operations, including fork operations. And if you do that, then you serialize those things. And it's a very tricky problem to deal with in just general code. Anyway, let's have a look at this, because I'm excited by this. And I think Eric did some really amazing work trying to support this, and it's actually making my life a lot easier than I thought it would be, because I'm just going to set this to 1. There's a Rails bug. I don't know what that means. Any platform where onon block does not exist. Oh, okay, so that should just be 0. because non-blocking is not supported. And what I think is nice about this design, coming back to the idea of the exclusive or non-exclusive fibers, is that it doesn't matter if we can't do this, it's best effort. You're not explicitly opting into it, so you can't expect that in every situation it's going to work. For example, on Windows, there are a lot of operations with file descriptors which aren't non-blocking. Windows just has a ton of things that it can't do in a non-blocking way, but it does work apparently for sockets. So maybe it's possible for sockets on Windows. So I am interested to do that, and what I want to do is I just want to go I guess it's redundant, but I'm kind of interested to see if that actually comes out as true now that we've enabled that. Invalid argument. So maybe that is more broken than I imagine. Was that the reason why it broke? Okay, so let's have a look at what that's doing and why it's breaking. Okay, setting it to 1 is obviously not the right thing. Fair enough. I should have seen that one coming. Okay, that is really awesome. Thank you, Eric. You've made my life so much easier. Because that means if we can get this test working, it's an implicit value for O non-block. Okay, right. Why was it broken? Test scheduler. Let's just kill that one. I think that should work. So it's obviously waiting, it's blocking on something where it shouldn't. So I'm going to guess that maybe this is not. So it's exclusive when it comes in here, but it probably shouldn't be. So why is that? Maybe I've stuffed this code up. So the fiber is exclusive. Is it even going through this code path? Okay, I think that's the problem. So this is the global function called fiber, and it invokes this C method called rbf fiber, and I wonder if I have stuffed it up somehow. Maybe the argument passing is not working. What? -1. What does that mean? I guess it might just mean whatever arguments you want. Okay, let's have a look at that. So it comes here, and then it calls this keyword version, and it puts that one there. And so we should come here and scheduler, current thread scheduler. That's interesting. Creating fibers still will always need to go through the thread scheduler. It can't use that one because otherwise you can never create fibers that are non-exclusive if you're on an exclusive fiber. Okay, is that behavior that makes sense? I guess we could try it and see. So it's basically going through this code path when we try and create the fiber, and it's coming here and it's returning nil, so it's not using the scheduler to create the fiber, so the fiber is not non-exclusive. By the end of this video, after saying non-exclusive and non-blocking this many times, I'm starting to see like the point of using maybe blocking and not exclusive. But I'm interested to hear your feedback on that. Right. So what I want is probably to use that one instead. I guess I could pass in an argument like bypass exclusivity, but for now that should be enough. That's annoying. Okay, I think argument's better. No, it's not, it's annoying. Is it not? Oh, okay, might just be that. What have I done? Get thread? Did you mean get thread? What the hell have I typed? Oh, God. Oh, it's only 2 AM. What? Okay, show me how I use this. Okay, so what was that? Okay, let's try that. It compiled. Oh, that's a pretty good sign. So now the fiber is not exclusive, and the test still didn't pass though, which is kind of annoying because I wanted to show it passing, but I wonder if that is still going through a blocking code path for some reason. So I've confirmed that should be working. Okay, let's have a look at IO read and see like actually, let's just double check. It is definitely non-blocking, right? Oh, it's not non-blocking. Hold on, didn't we check that before? We're not using a pipe. Okay. The reason why I was using a UNIX socket pair, this is really the same as a pipe, but not actually. It's actually a socket, UNIX domain socket pair, which is bidirectional on both ends. But apparently, as I said before, on Windows, while an I/O pipe is not capable of being non-blocking, apparently a UNIX socket is. And so I wanted to try and make this work on Windows. And to add to the mindfuck, like, it's a UNIX socket on Windows, right? So like, I mean, like, maybe they just should have called it like local socket or something else. I mean, it's very specific to a particular operating system, and yet it's supposed to work everywhere. And I guess it's part of the POSIX standard. I don't know. So it's a bit stupid. Okay, pipe. So we're gonna use the pipe, which should be non-blocking. And it did partly work, but that message was empty. And I wonder why that happened. Did we hit the scheduler? Probably not. Let me just have a look. So it's definitely non-blocking. True. And exclusive. 3 is not exclusive, so in theory, those operations should be waiting through the scheduler until we get to this 5, we execute the write, and then the data goes through and comes out and finishes. Are we calling scheduler run? Have I done something weird to stop that from working? Looks like we're not running the scheduler. Oh, I know why. It's using this. It's got the same issue as the fiber method. This should fix it. Oh, look at that! It passed. Epic. We can fix this one. It's the same problem. I think I should add argument. So over in thread.c, when the thread exits, I really need one of those like things where you can just jump to a method. I'm just too stupid to install it. There we go, that's what I want. And in fact, I'm in the thread, so I don't really need to do that because it's literally in front of me. Okay, right, so let's do a quick recap and summary before I need to go to bed. So what we implemented was the ability to jump between fibers that are exclusive and not exclusive. Fibers which are exclusive retain the existing semantics, and fibers that are non-exclusive using this syntax, which is hidden from the user because they use this new fiber syntax, fiber do end. That creates a fiber which allows transparent scheduling of potentially blocking operations. Before, you had to explicitly choose the IO would be non-block, but we've modified that code path so that all IO is non-blocking. Now, even if the IO is non-blocking, that doesn't actually impact its execution in a thread without a scheduler or in an exclusive context, because even though the IO is in non-blocking mode, Ruby will just wait until it returns all the data. It will put the read into a loop, and it'll go, okay, you're not ready yet, I'll wait until some data is available. And so those operations are still essentially blocking, even though internally it becomes a loop. In fact, you wouldn't even need to know. And so I guess from the ergonomics point of view, the user now just runs this code. And if I was to do something like this, because we're in the thread at the top level and the main fiber is exclusive, these operations naturally become blocking, which is fine because a write operation in sequence with the fiber over here is going to be fine. But yeah, I'm really happy with that actually. And I think this is really shaping up to be a fantastic way to write concurrent code. And so all you need to do is set a scheduler and use these constructs here, and then operations within those blocks becomes concurrent. And what's really great about this is I gave a demo before using net HTTP. Now it turns out that if you did use net the IO operations in this method become transparently non-blocking. You need to modify this code, because I had to do a little monkey patch to make the internal IO to go io.nonblock equals true. That was my monkey patch to make that work. But now this shouldn't be necessary. You can just write this directly and it will work. So that's super exciting to me, because it means that if you opt in and you make a concurrent fiber, then whatever code you use in here will become concurrent. And that doesn't mean that it's gonna work, because there's tons of stuff like data race conditions you can have if your code is just crap. But provided the code is like some semblance of sanity in its implementation, it should work just fine. And NetHTTP does just work fine, which is great. So I think it's the end of that presentation. I'm really excited by this, and I need to put all this together into a final write-up, and it'll be on my blog soon, so you have to see just the full model, the proposal, and all those other bits and pieces. And actually, I'm glad we got it working in the end, because it would have been pretty stupid to have a video where everything doesn't work. Yeah. Excellent. Well, thanks for watching, and feel free to join in again, ask any questions, Twitter. I'm always excited to talk about this stuff. Excellent.